Welcome back to our YouTube channel all about VLSI. So in previous session, we'll discuss the things related to physical design input files, right? In those files, we'll discuss some files like netlist file and .lib file. So in today's session, I'll discuss the things related to remaining input files. Okay, 1 minute. Let me share my screen. Yeah. Okay. So we left with the topics left file. So what is mean by left file? Left is a library exchange format. What it contains, and I'll discuss the things. So actually, left file contains the complete physical information of standard cells and meta layers, etc. So in this left file also it will be divided into two categories. First one is technology file and the second one is cell left. Okay, so what it contains means it contains the physical layout of standard cells, macros and IO pads, which means the complete physical information like the height and width of the standard cells, macros, what is the height, what is the width. So all this complete physical information is present in left file, and it also provides the physical abstraction of library cells, which means it shows the top level view of the standard cells, means height, width and top level view like pin information, pin width information, where the pin is located. So all this information is presented in this. So these are categorized into two types. First one is technology left. Okay, technology left, which means technology file, right? So what it contains the complete information of metal layers and wires information, etc. So where this file is used when they are in fabrication process, when they are manufacturing layers, so at that stage this file is used. So this technology left contains complete information of layers and wires. So what is the color of the layer, what is the width of the layer, what is the pitch between two layers, and what are the dimension of wires. So all these things. And see, includes layers, design rules, wire definitions and metal capacitance, all this information. And the second one is cell left. It defines the physical view of every standard cells and macros. Okay, see, it includes the pin locations, and it also contains blockages, keep out margins. So like this, it all this information is presented in cell left, technology left. See, it contains the process specification parameters like every parameter of metal layers and vias. Okay, how we are placing at which place we are locating the layers, and at what distance we are placing those metal layers, and what is the distance between metal layers, which means pitch, right? So and we are connecting two layers, so at that time we need one wire, right? So at that time what kind of wire we are using, which means fat wires, double cut wires, single cut wires. So all this information is presented in technology left file. Actually this technology left file is in the format of ASIC. I think you guys are familiar with what is meant by ASIC, right? American Standard Code for Information Interchange, which means it is human readable language. Okay, technology file is in human readable language, and the file generated for each technology node, right? So we are working with 28 nanometer technology, means it has some parameters related to 28 nanometers. If you are working on 4 nanometers or 5 nanometers, 7 nanometers, so for every nanometer this technology file varies, right? Because every technology node having different kind of parameters, so at the time this technology file also changes. So this technology file is dependent on technology, right? And design rules for each layer and bias, right? Every design rule like height, width, pitch, color, everything. Okay, see here. And it also contains the 1 minute. Draw here unit length. It also contains the unit length, units of voltage. Voltage will indicates with V, and current name here, power and resistance, capacitance value, capacitance name, sorry, and inductance name. So all this information also present in technology file. And see here, layer number. So we are using metal one layer. We named that layer as 1. And see here, color is white, and line type. This is the complete information of one particular metal layer, right? So what is the this is the color and line type, line style, and pattern. So this is the complete information related to one particular metal layer, right? So all this information is presented in technology left. Sorry, I'll remove all. Okay, fine. And second one is left file. What left file contains complete physical information, right? Complete height and width of the standard cells. So in technology, what is the main difference between technology left and cell left means technology left contains the complete information related to metal layers and vias, right? So in cell left we have complete information of standard cells, which means macros, IPs, all this information, physical information. Like, see, a text file that defines the physical abstract of every standard cell and macros, right? And it does not contains the transistor level information. I said you in before, right? It contains only abstract view, like where what is the pin location, height, width, like this information. It does not contain the complete transistor level of information. It only contains the pin and geometrical view, where the height and width of the standard cells, all this information. Okay, and it acts as a interface between logical design and physical implementation. What it means? So actually, in let us consider one AND gate means that AND gate all complete logical information is present in netlist, right? So in this cell left, the complete information of that AND gate, which means what is the height, what is the width of that AND gate, and what is the pin height, pin width. So where the pin is located, and where we want to locate that AND gate. So all this information is presented in complete physical information of that AND gate is present in cell left. Okay, see here. So I have one, sorry, and it also contains the lane. See here, pitch information, offset information, and max width. Okay, see, I'm having height. This is the height, and this is the width of my one standard cell, right? So from this is the origin. This is one XY. It also contains the XY symmetries locations also. So all this information is presented in cell left. Okay. And after that, SDC. SDC means synopsis design constraints. So what this file contains? Actually, this file contains the complete timing information and area information of these standard cells, right? Uh, we are giving, so when we want to create a clock, to define a clock in the clock in my block, then I'll use this SDC file. Okay, it is used to specify the timing, area, power of complete my design, right? it is the primary communication between the synthesis and physical design tools, right? So when we are, so before PNR we are doing synthesis, right? At synthesis stage we are using this SDC file. At synthesis stage we are defining the clocks, we are, which means we are creating the clock, we are creating input delays and input transitions, we set the delay, set the loads. So all the information is presented in this SDC file, ensures the final design meets. So it should ensures that our design should meet the performance, which means complete related to timing, how much speed it will work. So it completely depends on time, right? So this is the thing. See here, we are creating the clock. So here we are creating the clock. I named that clock as CLK1, and here we are defining the period, and we are setting the input delays, output delays, how much max delay, and uncertainty values and driving cell. Okay, and here also we are creating some group paths also. Okay, all this information is presented in STC. This STC file is, we are giving one of the input to synthesis, right? This is the thing. And after that, triple MC file. Triple MC means multi-mode and multi-corner. So what is the need of this file? So if you want to check my design at every corner and every mode, so to meet complete information, okay, so for that reason we are using, sorry, for that reason we are using this multi-mode multi-corner. So actually it contains the complete information of every corner mode and scenario. Actually it contains two modes, funk mode and scan mode, and it has five corners: RC based, RC worst, C based, C worst, and typical. So one mode and one corner is called as one scenario. Okay, we are checking for every scenario to meet complete timing wise and performance wise. We are checking our design by using this triple MC. See here, these are the cases I said you earlier, right? Scenario is equal to one mode plus one corner. So these are the, these are my corners: RCB, RC burst, resistance and capacitance, and C burst means capacitance burst, C best, and RCB and typical. So these are the things present in here. Functional mode, we are checking for functional mode. So these are the things completely related to triple MC. Okay, and after that we are having one another file, TLU place file, table lookup. Okay, so it stands for table lookup file. It contains the complete information of parasitic and capacitance resistance values, RC parasitic metal layers. So actually this file is used to calculate the delays. So before routing itself, actually after routing only we can find the wire length, and depending on wire length we can find the delays information, right? So before do the routing also we can find the net delays by using this TLU place file. Okay, all data present in TLU place file is completely technology dependent, which means I said you earlier in technology file related thing. So technology file also varies from different varies from 28 nanometer to 5 nanometer, 5 nanometer to 7 nanometer technology, right? So same way TLU place file also dependent on technology. Why? Because it completely thing related to routing, right? So it this file is given by Foundry, and that's it for today. So these are the These are all the input files which we are used for physical design implementation. And in future classes, I'll start floor planning stage. So these are the input files required for physical design. That's it for today. Thank you.